record, share screen. There, done. Good. So this is it. And I know it's hard sometimes, end of the day, you got to sit through a lecture. But like I said, on the tail end of this, work time today and then all day tomorrow, pretty much the only way I'll be up in your business tomorrow is if you just want to go over problems with me. I can help, whatever. So let's get to it. Our first example, you won't know why this lesson exists for about another 5 minutes. So let's just run through this and just treat it like any other problem. The only thing I'm not going to discuss with you today is intervals of positivity and negativity. I feel like that lesson yesterday that's pretty easy, huh? So that will be part of the assignment that you do. It will be part of the quiz, but I don't think it's something we really need to talk a lot about. But if you have a question, just let me know. So here's our first example. All right, we should be getting close to cruise control mode here. So step one, what do we do? Yeah. Yes, and just like I did yesterday when I set it equal to 0, I'm just going to take the lazy man approach and just erase f of x and put 0. You could do the same when you copy them onto your paper. Just don't even write the f of x, just write equals 0, right? Next step, pull out the GCF. And in this case, what is the GCF? I agree with that. And what's left over then? Excellent stuff. And then what do we do? The F word. Listen, that's fine. You guys really yesterday took to just talking about end behavior, or you got to talking about it later, and I think that's a good habit. So let's kick the end behavior to the curb, and we'll come back to it later. So let's factor, right? What does this factor down into? It's definitely a quadratic, so it's going to look like this. I'm thinking I'm going to need an x and an x. What are my signs going to be? One of each, one positive, one negative, bring down my GCF. And I'm pretty sure I'm going to want a positive 1 and a negative 2 just to create the right balance when I add them together. Right. The only way you're lost right now is if you haven't been here and you haven't watched the videos. But like, assuming that you've been around and you've been doing some factoring, this is like, yeah, like, why are we talking about this? Let's talk about red guy first. What answer do we get from red guy?
0.
Correct. What answer do we get from purple?
Either one.
Yeah. And finally, what answer do we get from yellow?
2.
If you're still sitting here right now wondering what's happening and like, why are we doing this? I literally took these exact same notes yesterday and the day before. It's what's about to happen that is why this lesson exists. We're about to come up with, I think the word I'm searching for is an incongruity, or a contradiction. And sometimes in math, one rule says you have to do this, and then you realize that I can't do that. Here I am trying to follow your stupid rules, and I can't do this. This graph is going to present that dilemma. So I'm going to make my axes. Let's get ready to graph. X-axis here. Y-axis proportionally, I don't know, maybe like here. And then I'm going to make some tick marks. I'm going to make a mark at -1. And then I'll make a couple marks over here for 1 and 2. Business as usual, huh? So I'm going to make a mark at 0. I'm going to make a mark at -1. And I'm going to make a mark at +2. Now it's time to have the discussion about end behavior. This is the right time to talk. All that stuff a couple days ago, we were a little early, I think, jumping the gun. Now we need to know, what is the end behavior on this function?
Up.
It is up. Right? It's not even up for debate. Like, we see that there's an even power on the x. There's a positive number 1 in front of x to the 4th. And so we know that the graph ends up on the left. And we know that the graph ends up on the right. And this is where you have your moment. And you see, if you're paying attention and not thinking of something else, you see very soon why this day is necessary. If I follow this sketch logically, and it slices down this way, it's got to come back up and slice through this way, and then it's got to come back down, and it should end down here, right?
Okay.
But this is in math a contradiction. This is an impossibility. One law is telling us that the behavior of the graph says to go up, up, and that is not up for debate. This graph will go up on both ends, but how is that even possible when the picture of it forces us to think that it goes down, up, and then finishes down?
Let's go back to different at the same point.
It just doesn't go.
It goes down, up, down, up.
Correct. I'm going to show you what the graph looks like really quickly, and then I'm going to explain to you. You're going to get this with perfect clarity today. Here in about a minute or so, you're going to understand pretty well what's going on. The graph of this function actually looks like this. It is going to cut through here, and then it's going to come back up, and it is going to hit this, and it is going to back away. And there is something in the problem. There's something in your notes and on the board right now. Well, not right now because I scrolled away from it, that tells us why the graph behaved like this. This right here is what we call casually, it's not an official math term. It's what we call a bounce root. And there's something about it that made it bounce. Because you see now that that all fits, doesn't it? It ends up, up. The thing is, we're not used to that. We're not used to the graph coming up, touching the x-axis, and then chickening away. Anyone want to take a stab at why? You don't know this yet because your teacher hasn't told you this yet, but the number of factors that you get, or the number of zeros that you get from a factor, is directly exactly the same as its degree. What is the degree of this red factor?
2.
Then it will give us 2 answers. And you might say, well, that's a bunch of hooty-doo. I don't get it, because there's only one number in the world that I could put into that red circle and make 0. And you and I both know dang well that it's 0, right? So what's the other answer? 0. You might go, what is this guy smoking crack? No. Sometimes in mathematics, one answer has to do the work of many. It's called multiplicity. That 0, Z-E-R-O, has multiplicity of 2. The way we write it, instead of writing the same thing twice, because that makes us look crazy, is we go like this. We say x equals 0, and then in parentheses, we put a little, oh, I meant to use my skinnier pen so you can actually see it. Hold on just a second. Times 2. That is your new notation today for multiplicity. And when you see a 0 that has multiplicity like that, it's going to hit and back off. That's what causes this to be possible. Now, I want you to see something. I'm going to head over to Desmos real quick, and I'm going to graph this. I want you to take a peek at it with me. I doubt it's still up here. Yeah, it's not there. 2, oh no, x to the 4th minus x to the 3rd minus 2x squared. So I'm way zoomed out, so I just need to go back to the default. And sure enough, that's what the graph is, just like we had predicted. I want you to look, as I zoom in on this, that this is the bounce root that you see happening right here. Watch what happens. I'm so sorry if you're lost right now, because then this part's really going to lose you. But watch what happens over here in the typey box. I'm going to take this whole function, and I'm going to buff it. I'm going to multiply it by 2 more x's. In other words, I'm going to multiply it by x to the 2nd power, and I want you to see what happened. Can you see what happened?
It went down, down.
Let me put the old one up on the board, just so you can see it again. And then I'm going to, it's a, would you say a skinnier bounce? That's a pretty cool way to say that. So I'm going to take the, I'm going to let Desmos do its magic. And the black one is the new one, and the blue one is the OG. What could you say to me happens when I increase the multiplicity of my root? What, just try to describe it to me. What happens? What's the difference between the blue graph and the black graph? Thank you so very much. I really appreciate that. Okay, since you don't want to answer that question, listen, here's how bounce roots work. A bounce root comes in and it touches the axis and it bounces off. But if I increase the multiplicity of that root to like a 4, it starts its approach to 0 sooner. it does not mean, despite what that looks like I bet it looks to you like right here where I'm moving my mouse, that it's already come to the x-axis, right? That's not true. That's just a pixelation issue. If I kept zooming in on this again and again and again, and I sat here for 30 minutes and just kept zooming in and in and in, you would see that that black graph is still not to the x-axis. What happens is when you increase that multiplicity, it accentuates that coming in for a landing thing. What do you think is going to happen if I were to take this and paste it again, but I add 2 more factors of x? If I change this to x to the 4th, what's going to happen?
It's gonna be longer.
It's going to be even more flippin' pronounced. And now look at how pronounced that coming in for a landing is. You just learned something today, hugely powerful, that if a 0 occurs twice or 4 times or 6 times or 8 times or 10 times, it does not cross through the axis, but rather hits it and backs away. What are all those numbers that I just said? 2, 4, 6, 8. What are they?
Even.
Those are even. So for your notes, what you need to know is this, that if a 0 has an even multiplicity, it's going to bounce off. And the more of them there are, that bounce is going to look flatter, like it has a flat bottom or a flat top. Clear? Okay. So that was the first example that I wanted you to see. Let's do another. Example number 2. Same old, same old. Let's get through this early part as quick as we can, right? Let's not drag this out. So step 1, I'm not even going to ask you. You stop me if I go too fast. I'm going to set it equal to 0. And then I'm going to pull out a greatest common factor, which in this case is negative and 2 and x to the 3rd. And that's going to leave me with x squared minus just regular x minus, I believe, just a 12. We doing okay? This is the kind of thing we've practiced enough that we can pretty much just Teflon cruise right through this. And then I'm going to factor down the white part. So I'm going to be left with negative 2x to the 3rd times x minus 4 times x plus 3 equals 0. So my zeros are from the red guy. What do I get?
0.
I get x equals 0. But I need to put the little parenthetical comment. How many zeros are going to come out of that red bubble?
3.
3. Remember, it's directly related, the same as the degree of the factor. So there will be 3. So I'm going to put a little times 3 in parentheses like that. What am I going to get out of purple?
4.
And what am I going to get out of green or yellow? Negative 3. Good. So business as usual. I'm going to set up. Everybody okay? Can I scroll this far? Okay, I'm going to set up my axes, x-axis, y-axis. I need to go to, why did you use yellow? I'm going to go to negative 3 and positive 4. So there's not going to be much difference between the lengths that I have here. So I'm going to make my tick marks across to left 3, 1, 2, 3, and then across to the right to 1, 2, 3, 4. And then as I always do, I'm going to make my marks. I'm going to make a splotch at 0. I'm going to make a splotch at 4. And I'm going to make a splotch at negative 3. So according to what we've learned before, if you had not sat through this lesson today, or what we've sat through so far, you would assume that the graph of this function, by the way, what's the end behavior? Going back up, can you tell me? Yeah, it's a high-low. So we know that it comes up high like this, and we know that it ends low like this. Right now, do not sketch the graph, because this is what, prior to this moment in time, this mistake that I'm about to make is what you would graph this like. You might be sitting there saying to yourself, I really think my teacher's losing it because I don't see anything wrong with that graph at all. I want to show you what it actually does. There's a little bit of flatness in here. You ready for this? Ready? So what you learned a few minutes ago is that an even multiplicity root causes it to bounce away. Here's what an odd higher degree multiplicity root does. It causes it to go like this. Do you see how I have a little flat portion there? That's what odds do, is they don't come in for a landing and bounce. They flatten out, come in for a landing, and then come out the other side at the same angle as they went into the one side. You see that little bit of flatness there? Yeah, a little extra snaky, huh? That's what that odd multiplicity is going to give us. And that multiplicity, that odd stuff is going to happen wherever the multiplicity occurs. As you'll see in these next couple of examples, the multiplicity doesn't have to occur at 0. It can occur wherever it wants to. What do you think happens if I buff this from x equals 0 times 3 up to like x equals 0 multiplicity 5? It'd be a longer landing, right? So now this part right here comes up sooner and it's flatter for longer like this. And that's just going to keep happening. That flat part is going to be more and more stern and accentuated as you increase the degree. So far, so good? Good. Next one. You doing okay? All right. Are you guys doing pretty alpha skibbity sigma? How did I do?
Skibidi Ohio.
Skibbity what?
That.
I just got Zach to just shake his head disgustedly at me. He just picked up his pencil and was like, I'm going right back to my notes. I can't even handle what's going on right now.
That's what that Skibidi Ohio.
What's the matter? Don't you think that was sigma?
No, it's fire. Don't think that was fire.
So yeah, teach me stuff, just not right now. So we're going to set this equal to 0, and then we're going to pull out a greatest common factor. You know all this stuff. So we're going to pull out x to the 4th, and that's going to leave us with x to the 3rd minus 2x squared minus 4 regular x's plus 8. What kind of factoring is this going to be? Grouping, right? This is draw the wall grouping. So I'm going to give it a little divvy whoop like this, and then I'm going to GCF the left half over here. The left half has a commonality of x squared, leaving behind x minus 2. And then after that, after the wall, we bring down the minus sign, we pull a 4, and that leaves x, change the sign to. Just cooking right along here, huh? See why we do factoring first. Like this would be miserable if I had to teach factoring on the fly. So we're left with our GCF x to the 4th. Don't forget about that little fella. And then we have our yellows, x squared minus 4. And then we have our whites, x minus 2. Whew. Are we done? Heck no. We got ourselves a, what's that thing called again?
Yeah.
Betcha. We got ourselves a difference of squares. So here comes the answer in its final factored state. X plus 2, x minus 2, x minus 2. And of course, could I have written x minus 2 squared?
Yes.
You betcha. So we see multiplicity occurring in 2 different places. Ay, Dios mío, and that's okay. Multiplicity doesn't just happen at one spot. It happens wherever it was meant to happen. So let's talk colors as always. What does red guy give us? He gives us x equals 0 4 times. Very good. So x equals 0, multiplicity of 4. You can already see what that's going to be. Is that a bounce root or a flat crosser? That's a bouncer because 4 is even. Very good. What is purple going to give? -2, and there's just one of those, but look at these little homies right here. They're the same, aren't they? So what do we get?
Plus 2.
X equals 2.
The x squared.
Multiplicity of 2. That's just a times sign. Times 2 is what that means. Oof. So let's graph. By the way, end behavior is down up, correct?
Mhm.
Okay, so low high is end behavior, so we should be good to go. And if we follow the laws of the multiplicity, then everything, all the puzzle pieces just have to fit into place. All right, there's not going to be like trickery. But my zeros are pretty symmetric actually, so I can just keep a nice squarish grid like this. All right, so I'm going to make tick marks to the left, -2. I'm going to make tick marks to the right, to +2. And then it's time to start making some splotches. And by the way, I'm setting a terrible example when I don't label my x-axis, so I apologize, but my bad. 0 gets a splotch, so kapoof. -2 gets a purple splotch, kapoof. And then 2 gets a yellow splotch. So we said that the end behavior is low high, so let's make this fit. Low means it's coming out of the purple dot like this. High means it's coming up off the yellow dot like this. Here we go. What kind of root would you say? What kind of behavior are you going to see at the purple dot?
Normal. No.
I was hoping someone would say that word. It's just what we've been doing. So purple's totally normal. It's a single multiplicity. So we already know that this is just a basic non-snaky crossing root like this. Oh hum. What kind of behavior are we expecting at the 0, the red one?
Down or the
long-
It's a really flat bouncer, isn't it? And so this one's going to come down for its landing pretty quickly. Sorry, it's not perfect, but it's going to come in. It's going to try to land. It's going to be a pretty pronounced flat landing, and then it's going to stay flat when it comes up and out like this. And then what kind of behavior are we expecting at the yellow root?
It's a little bit of a
Another bounce, but not as sternly pronounced as the red one. And so this one's going to do its climb, but then it is going to work its way back down, and it's going to have a flat approach, and then it's going to bounce away like this. And I will erase, of course, that one there. So got it? Where are you at right now with your understanding of this? It's hard for me, I'm the guy that it's hard. I don't get a perfect reading. Let's another one maybe help us out. Okay. What are you? Okay.
Chase's last. He has a little bit.
So that marks 3 examples done. Is that 3 down, correct?
Yeah.
Let's go again. And hopefully whatever your ranking is, like right now on a scale of 1 to 10, you might be a 5. Maybe after this next one, you're like, okay, I feel like a 7. That's always the goal. So let's do another. And my plan was to do the first homework problem with you. So let's do this. We'll wrap up the notes, and then I will keep the recording going and do the first problem of your homework with you. Now, you don't have to worry about doing anything tonight. Like I said, you got a ton of work time tomorrow. So last example is this one. Yeah, so
162.
it is minus 162. So I'm going to get rid of the f of x equals, and I'm going to set this equal to 0. And then I'm going to do, the thing that we do. There's not a lot of GCFage going on, but there is a GCF. What is it? It's negative and it's 2. Very good. We want to get all that out of our way. Definitely the negative's not really something we should consider optional. The 2 is more of a luxury. And then that leaves us with x to the 4th minus 18x squared plus half of 162. Like this. What is the white polynomial called? We've had some work with this.
Look-alike.
It's called a lookalike. And with lookalikes, we we approach them as if they were quadratics. That's the vibe of it is like it feels pretty quadratic-y to me. Except when I break down my x to the 4th, I'm going to go halvesies here and halvesies here. What are my signs going to be?
The same thing.
Both minuses, yeah, for sure. Because they have to multiply to make a positive and add to make a negative. And they're both going to be 9s, huh? So we realize that we've got ourselves a little bit of a not done situation here. What are they called?
Too much work.
difference of squares. In fact, I've got a pair of differences of squares. And so if I color code this for you, this yellow one is his own thing. He factors into x plus 3, x minus 3. And then if I do this, we'll do purple. If I do the purple one, he factors into his own batch of x plus 3, x minus 3. And finally, we look at it and say, whew, done. What are we going to get out of this red one? Zilch. Very good. You learn well. Remember, if it doesn't have a variable, it's got nothing to offer us. Okay, it's just throw it aside. It's gone. Tell me about my zeros. What are they going to be? Did you say group them? Is that, did you? Oh, I didn't. Yeah, like there's groups, pairs of them, aren't there? So what's the first zero that you see?
X equals -3, and it's gonna be times 2.
I agree. So look at where these little arrows are pointing. You could not possibly disagree that those are the same, right? So they each give us the same answer. So we can say that x equals -3 is a root or a zero. You're going to hear me start trading those words in and out. You can do the same thing, roots, zeros. And that's with a multiplicity of 2. And then these ones with the little red underlines are, of course, the same. And what do they give us? X equals +3, but again, with a multiplicity of 2. The fundamental theorem of algebra states that you will have as many answers to your polynomial function as the degree that you originally had. So if I go into a problem and it originally has degree of 4, then I know that I better find 4 answers than I just did. So we're done with the algebra part of it. Now let's get on to the graphing part of it. So my answers are -3 and +3. So I need some axes that are pretty symmetric. Holy axis, Batman. Ooh, that's better. That was obnoxious. -1, -2, -3, negative or +1. Brandon, you doing okay, buddy?
Yeah.
You sure hanging in there? Okay, so my answers are -3 and +3. And so I'm going to put some splotches. I don't remember what my colors were, but it's okay. I'm just going to go kaboom and kaboom. What is the behavior at those? It's up and up. We know the end behavior is up and up. I think it's up and up. Did we?
No, it's down and down.
Oh, it's got a negative in front. So it's a down, down. So our behavior is going to go down, down. And in order to make this work, what's it going to look like? What's it going to do? How does this work? What does it do at this first dot?
It comes in and lands.
It does. It lands and then it takes right off. Like you've seen those C-130s do that out of the military base, how they come in and then they just take right off. It's, I don't know what they call it, like a touch and go or something.
Yeah,
Is that what it's called? And then the graph's going to dip down here really far, FYI, further than I want to graph it. We're just sketching, and it's going to come up for a landing, touch and go, and out it goes. So that concludes the notes. What I want to do now is get you onto assignment number, whatever it is, and I actually want to do the first problem with you. So we're still working together, but we're making headway on your homework. 2 birds, 1 stone. Sound good? Okay. The first problem on your assignment number 9. Oh, by the way, the assignment's on Canvas.
How many questions are on it?
6 questions, I think. Maybe 8. I think 6. Because I know that they were a pain in the butt to write, and I think after I wrote 6, I was like, I'm gonna be done now.
Close enough.
Yeah. So this is assignment. What's the assignment number again? Number 9. So this is assignment number 9, problem number 1. And if you don't want to go to Canvas right now, I'll just put it up here for you. It says f of x equals -x to get good, noob, equals -x to the 6th minus 2x to the 5th plus 4x to the 4th plus 8x to the 3rd. So this is good. We're doing your homework together. How fun. Hey, I got a new question for you. What do we do first?
GCF.
Oh, maybe equals 0.
Set equal to 0. Now what do we do first? GCF. What is the GCF? Love it. Leaving behind regular x cubed plus 2x squared minus 4x minus 8. This feels a little bit similar to one of the examples that the third example that we did. They're quite similar, actually. But I wanted to do this one because multiplicities occur in different places and they're different types of multiplicity. So I wanted you to get eyes on one of these. So that's why I'm recording it. So it's there. All right, so we're good to go. And then of course it's a grouping problem. So we're going to wall this little sucker down the middle. What is the GCF of this left half?
X squared.
Yes. Leaving behind.
X plus 2x. Or 2, just 2.
And then the second half, we bring down the negative or the minus, and we pull a 4, leaving behind.
X plus 2.
So the current state of affairs is I have 3 factors right now. I have one factor named negative x cubed. I have a factor named x squared minus 4. And I have a factor named x plus 2. Woo, Dios. By the way, if you're listening well, how many answers will there be to this problem when we're done?
6.
6. Fundamental theorem of algebra says so. Look up at the top. It's a 6-degree function. We're getting 6 answers, right? Come hell or high water. We're going to find all 6 of them. What we do. What do we do now?
The difference squares.
For sure. Factor this little mambo jambo down. What does he become?
X minus 2 and x plus 2.
Sure. We now have all 6 answers present and accounted for. I can see them. They're out there in the open. What am I going to get out of this red one?
X equals 0.
X equals 0
3.
times 3. He's a triple. How about purple?
X equals negative 2.
Purple.
X equals negative 2.
Purple.
Plus 2.
X equals 2. I was hoping I wouldn't have to say purple again, because anyone watching the video would think, I hope they called 911. The man's having a stroke. So now let's talk about let's talk about the yellow. You kept saying negative 2.
Well, because that's what I got on my
Doesn't make it right.
That does.
You're weird.
So back to
What do we get out of the yellows? This is your moment, Brendan.
I don't know.
It's your time to shine. X equals negative 2
times
times 2.
2.
Good. So I wanted you to get eyes on one of these. I wanted to do this with you. There's multiple types of multiplicities all in the same problem. Let's graph this bad boy. You can see all 6 answers. They go 0, 0, 0, 2, negative 2, negative 2. Boom, there they are, all 6 of them laid out in a row. Zip it, Corky. So we got to go to negative 2 and 2. I'm gonna put in some splotchies, some points. 0 gets a point. Boop. 2 gets a point. Boop. And negative 2 gets a point. Going back up to the beginning, what's the end behavior?
Down, down.
Are you sure?
Yes. Yes.
Okay, good. I just want to make sure. So we know what to expect. We know that the graph will end down here somewhere, and we know that it'll end down here somewhere. So what kind of behavior is occurring at the yellow dot? What is it?
Bounce.
It's a bouncer and it's not very pronounced. So it's a pretty standard parabolic sort of bounce route. So it's going to come up and it's going to hit and it's going to bounce. There's not a lot of flat landing approach kind of stuff going on there. What is it going to do at 0?
It's going to flat up.
It's going to be a flat crosser. So you guys, if you want to start giving them names, you got like flat bouncers, parabolic bouncers, flat crossers, whatever, call them whatever you like. But it's gonna go down and then it's going to come up and it is going to flatten out, snake a little bit, and then come up like this. And then finally, what is the behavior at the purple dot? Normal. It's a normal crosser, so it's going to come up and it is going to cross, and that is that. Oof. Funky little monkey. Do you have any questions for me?
No.
That makes for a long day for you, and I do know that, and I am sorry for that. So work for 5 minutes. Maybe you can get a half a problem set up or done, and then tomorrow we will work. And I will have all answer keys up tomorrow. Promise.
I got a very important job. Appreciate it. I'm just so
I need
excited
you to do
for when I have to leave it.